Making the decision to build your application on the blockchain and embrace the Web3 world comes at a significant cost. You're essentially sacrificing the user experience in order to have your backend stored on the blockchain. What I mean by this is most Web3 applications today have a requirement for their users to understand the blockchain, understand what a wallet is, understand what tokens are, have a wallet set up with funds native to that chain in order to even begin interacting with your application. This is arguably the biggest drawback to deciding to build your application in a decentralized manner on the blockchain. Right off the bat, you're essentially excluding 99+% of your audience with that level of requirement to understand what the blockchain is, have a wallet. Most people do not have this foundational understanding of what the blockchain is. And as Web3 developers, we shouldn't expect users of the mainstream world to understand what these technologies are. It's like if you ask the typical Facebook user to say, hey, how does a database work? Or how does your Facebook authentication work under the hood? That isn't a reasonable expectation to have for your users. The interesting thing about this is most of the Web3 applications that we've seen reach mainstream adoption today have completely voided this requirement to understand what the blockchain is, understand what a wallet is. A great example of this is the Reddit digital collectible NFT collection, or just digital collectibles, as they conveniently left out any of the Web3 and blockchain terminology intentionally and created a user experience where you didn't need funds, you didn't need to know what a blockchain is, you didn't even know that it was occurring on the blockchain if you weren't already familiar with what was happening under the hood. The expectation that we have for users to understand what a wallet is partially due to the technical design of the blockchain itself. Today, I'm going to show you how account abstraction has an answer to almost all of the major Web3 UX issues that exist today, and give you a brief overview of where it's evolved from 2016 to the EIP-4337 that was introduced and proposed in September of 2021. Before we dive into the fancy stuff of what account abstraction is, let's quickly recap what we know about Ethereum accounts in general. So if we make a nice little purple section here, there are two kinds of accounts that you can have on the Ethereum ecosystem. The first one is called an externally owned account, and this is called an EOA. And the second kind of account that you can have is called a contract account. So let's give that a nice blue color here, and let's name this contract accounts. The key difference that you probably care about is externally owned accounts you can think of as a user. So for example, I have this MetaMask wallet installed, I have this Coinbase wallet installed. These are both examples of externally owned accounts. They're wallets that you're familiar with, that you sign transactions and send them to be mined on the blockchain essentially. Contract accounts are smart contracts. They're code that lives on the blockchain and aren't owned by a user or controlled by a private key. Externally owned accounts, if you have the private key, you have full control over what that externally owned account can do. Contract accounts don't have a private key. They are simply just code living on the blockchain. Whatever that code defines is how that account will behave. The reason that we have this world of poor user experience in Web3 today on Ethereum and EVM-based applications are because externally owned accounts are the ones that need to sign transactions, which is required every time you want to write information to the blockchain. This is probably the most important sentence of the whole video. Externally owned accounts are the ones that need to initiate a transaction. This is the reason why Web3 exists the way it is today and why we have such crappy user experiences, because externally owned accounts are basically crap. They can do one thing essentially, and that is sign and initiate transactions. That transaction could be to another EOA, or it could be to another contract account. So if I want to send Bob 1 ETH, I'm going to send a transaction to another EOA. If I want to mint an NFT from a drop, I'm going to be interacting with a contract account, which code defines that token being minted or transferred into my wallet. If I paste this nice little image that I made here, you can see the typical flow of setting up a new EOA. And this is probably a flow that you're familiar with if you've entered the Web3 world already. You're creating your wallet, so you've installed this kind of browser extension, or maybe you have a hardware wallet that you've bought. Either way, you're creating an account. You need to store the private key securely. The private key gives full control of your wallet. If you lose that value, you're basically doomed. You'll never be able to recover the funds within this wallet. Typically, to interact with the smart contract, the client is going to ask you to pay the gas fees to interact with the smart contract and write that information to a block on the blockchain. So you'll need to purchase funds. This often requires a KYC process to buy funds from a place like Coinbase, transfer those funds to the wallet that you've just installed. Then you can begin to connect your wallet to the application, initiate the transaction, pay the gas fees, wait for that transaction to go through. Transaction is eventually confirmed, and you'll repeat at least 3 or 4 steps of this process every time that you're going to write new information to the blockchain and initiate that transaction from the EOA. Obviously, what I've described is a horrific onboarding experience for new users. Imagine a grandma trying to set all of this up just to create an account and interact with your new Web3 application. It's not going to happen. And sadly, this is what we're used to. And the expectation that we have of users is to have a fundamental understanding of keeping their private key secure, setting up their wallet, transferring funds around in order to be even able to interact with our application. A poor user experience is only the beginning of why EOAs, externally owned accounts, are so crappy. I've just done some quick Googling of losing funds, Bitcoin, millions of dollars of lost cryptocurrency after man dies with only password, $321 million in Bitcoin, but he can't access it because he lost his password. Guy locks his phone with potentially 6 million in crypto. The risks associated with using EOAs are drastic. This is an all or nothing approach. If you have the private key, you can do everything, send any amount of funds anywhere from that wallet. This has happened so many times. I know so many people who have leaked their private key while trying to code some Web3 application, send it to GitHub, it gets pinged instantly by bots, and all of your funds are immediately gone. This is just one of the risks associated with EOAs. You'll see countless posts on Twitter of people losing their Bored Apes. It was even a meme for a while of, I just lost all my Bored Apes. This is a very real issue with EOAs. The reason is, if you have the private key, you can sign and send transactions to the blockchain. Doesn't matter what those transactions are. That is the definition of an EOA. That's what it does. That's what its purpose is. This system of EOAs is almost ignorant of what's happening in the real world. People make mistakes and people lose access to things all the time. And that's what's happening in the real world. Imagine if you lost your credit card and therefore you completely lost access to all of your currency in your bank accounts. It's just not realistic and not up to par in terms of even what we're used to in the Web 2 or centralized world. With a credit card, you can say, hey, I lost my credit card. Can you please cancel all of the funds being transferred? Banks even go ahead and detect fraudulent transactions as they're going out of your bank account. You can swap funds between accounts if you lose access to it for any reason. You can stop transactions as the funds go out of your wallet if you don't agree with them. You can set up restrictions on what's happening in your bank account at the very beginning of your account, defined in your settings to say, hey, I'm never going to spend more than $3,000 on this card, for example. Let's not accept any of those transactions above that limit. Where I'm going with this is account abstraction, as we'll explore next, removes the need to have externally owned accounts and allows the user to have contract accounts to perform transactions on the blockchain. But what does that even mean? Why would you want to have a contract account over an EOA to perform transactions on the blockchain? The reason this is so exciting and matters at all is anything you can imagine and then write in code on a smart contract is available as a feature on your contract account. Literally anything you can write in code is therefore available as a feature on your contract account when you create it. This opens up so many new possibilities. You could have things like permission controls to say, let's set up 5 people on this account and 3 out of 5 of those need to approve a transaction in order for it to go through. You could have recovery mechanisms for your wallet to say, hey, if I lose access to my account, can you please transfer ownership of the funds to a new account that I do have access to? You could use things like transaction limits to say, hey, I'm not going to spend more than 1 ETH in a single transaction to specific addresses, or anything, literally anything you can imagine and write in code is possible on an Ethereum account. In terms of Web3 apps, this opens up so many new opportunities. And one example I'm most excited about is, for example, if you're building a Web3 game, you could create contract accounts for people under the hood as they sign up for your game. So there's no longer a requirement to know what the blockchain is for your players. They don't have to create an account. They don't have to load their wallet up with funds. Then you can maybe say, hey, I'm going to give myself permission to interact with the game on this wallet's behalf with specific functions, with specific function parameters. The user can interact with your game as they would with any other game. They've completely voided that step and that requirement to know what the blockchain is, set up a wallet, transfer funds, go through the process. They literally just play the game. You manage the blockchain technology under the hood, and they don't even know that they're working with a blockchain or a Web3 game until they come to a realization that, hey, I've been earning digital tokens this entire time, and they can have the full freedom that we know and love in the Web3 space to trade and utilize those tokens in other aspects of the world. But why are people talking about account abstraction right now? This actually isn't a new concept. Account abstraction has been around as an idea since 2016. And the first kind of proposal to introduce this was EIP-86. You can see the summary here. It says abstracting out signature verification, allowing users to create account contracts that perform any desired blah, 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 blah. Very familiar terminology as we're familiar with in this video, hopefully. And the idea has been around since 2016. There was then EIP-4337, and I'll let you jump around and read these as much as you want. There'll be links in the description if you are very curious. There was then EIP-3074. These are all attempts to implement this kind of account abstraction so that users don't have to have the problems associated with EOAs. The thing is, all of these require a consensus layer change to Ethereum. And from the research that I did, Ethereum improvement proposals are kind of slowed down by the requirement to have a consensus layer change. What's different about EIP-4337, account abstraction using alt mempool, which is the latest one? You can see this is in draft, whereas the other ones are in a stagnant state. So these three are all in stagnant states, whereas EIP-4337 is the latest edition of the account abstraction proposal. The difference is it avoids consensus layer protocol changes and instead introduces a higher layer abstraction to implement the kind of same goal to abstract away the accounts from being EOAs and uses smart contracts to be able to perform the transactions. Reading through the implementation of EIP-4337 at the kind of Ethereum layer level is a little bit confusing, and I've tried my best to kind of simplify it from what I understand. Essentially, instead of changing the consensus layer itself, they introduce a new pseudo transaction. So it's not a transaction, called user operations. So I've drawn this little diagram to try and summarize it as best as I can. Users create these user operations. Those user operations go into this kind of waiting zone called a mempool. And that's where this alt mempool part of the proposal comes in. And they kind of sit in this little cloud environment. Don't know why I put it in a cloud, it's just kind of a pool of user operations. There is now an entity called bundlers, and Ethereum nodes, the people that are kind of performing in the ecosystem of Ethereum to write new blocks to the chain already, can opt in to be a bundler. Bundlers take multiple user operations and bundle them together into a bundle transaction. That bundle transaction gets sent to a smart contract called entry point. Entry point is a smart contract that's called a singleton contract, which means there's only one of these on the blockchain. And it does that by kind of reading through the code of the smart contract and being able to verify that there's only one of these on the blockchain. I didn't really understand that part, to be honest. But there is one entry point contract on the network. The entry point contract accepts the bundle transaction and then essentially runs what is in the bundle of transactions here. So it takes in the bundle and then says, hey, I'm going to run this function I have called handle ops. And it says, hey, what do I do with all of these transactions? I'm going to handle them. It's then going to distribute them to the accounts that are included in that batch of transactions. Then the smart contract wallets must implement two functions or two interfaces on the smart contract wallet interface. The first one is validate user ops. So it takes in an operation from the entry point contract and says, hey, is this valid? Did this really come from you? Is this in agreement with what we've defined in the smart contract? Maybe it doesn't meet the spending limits, or maybe it doesn't meet the permission control requirements that you've defined in your smart contract. If that returns true, then it executes the code that is actually defined in that transaction. So I just want to make sure this might not be 100% correct. This was my interpretation of the proposal here, as well as a lot of different resources that I read and videos that I've watched about this topic. So I want to make sure I'm not saying this is for certain. This is my interpretation. The bundler is incentivized monetarily to bundle these user operations. The entry point contract is able to function because the user pays the gas fees to the contract before executing the transaction. Any of the remaining funds from that gas fee go back to the wallet that executed that transaction. So this doesn't pay any of the gas fees. It's kind of just saying, hey, do this, pay me the gas fee that might happen. I'll give you back the remainder. So that is very typical with any kind of operation that you're going to write to the blockchain. So that's my summary of account abstraction. And as you can tell, I'm very, very excited about this new behavior being brought into Ethereum. If you enjoyed this video, maybe you'll like this one up here. If I remember to do it, hopefully I do. Check that out. If you don't like the look of it, damn, subscribe to the channel instead so you don't miss the next one. Appreciate you watching. Thank you and goodbye.